Okay, we move to the next problem, fundamental F59. So here you have the road, this kind of curved road. This road is supported by smooth general bearings at A, B, and C. So these three are general bearings. Okay, so you have to check how actually what are the reactions for general bearing. Okay, and it is subjected to two forces. One is for 100 Newton load along this direction, which is we define as y. It is defined as y, and then along this 600 Newton, which is parallel to z axis. Okay. And then the question asks to determine directions at these supports. So basically, you need to find directions at A, B, and C. Okay. So we have to draw the free body diagram. Before we proceed, we need to find the free body diagrams. So how about the general bearings? General bearings, then remove the general bearing here, right? And then what do you have? You have the one in this direction, right? Rx and also mx. When I draw a double arrow like this, it means that it is moment. A single arrow, it means it's a force, Rx and mx, right? And then you have Rz and also mz. Single arrow and double arrow, okay? Rz is the force, mz is the moment like this, right? How about in this direction? So there is none. There is no reactions, okay? Because that's the general bearing. General bearing doesn't have reaction in the its axis, right? Same goes to B. So basically at B, you have the okay. So this is let's go back. We do as AX, AZ, okay? So it will be easier. AX and AZ. So here you have BX and BZ. Okay? And at C, the third support, you have what? It is not this, and this is correct, but this is CX, right? CX. And you have CC? No. Now the direction is in this direction. CY. Why is that so? That's why you need to go back and see the figure correctly. So the general bearing is like this, around this road. General bearing allows the movement and rotation in this axial direction, right? So there is no reaction here. So the direction is in the other two, X and Z, Y. This is Z, so Z is free. Here is different because of the configuration. This portion of the road actually it goes in positive Z, right? Vertical. But this one, this portion, it goes along Y, right? So Y is free, but X and Z are constrained. This one is different. This one is along Z, so X and Y are constrained. Alright, so you have to be careful while checking. I mean, while understanding these reactions, right? If you check the reactions for general bearings, actually you will have moment like this. So you should have moment as well, right? But actually you don't need moment here. In this problem you don't need moment. Why you don't need moment? For the general bearing, you don't need moment. Because actually, if for bearings, for any types of bearings, if you have more than one bearing, if you have more supports, actually you don't need the moment. You need to find the moment. Okay. Okay. So you can remove the moments fractions. Okay. So how many unknowns now? AX, AZ, BX, BZ, CX, and CY. So you have 6 unknowns that you need to find out. Okay. Can you find it? Actually, you can, because at least you have 6 equations. Fx equals 0, Fy equals 0, Fz equals 0, the first 3. And then Mx equals 0, My 0, and Mz equals to 0. So actually you can find that. You can write any equation that you want, but actually now, because we need to write lots of equations probably, so we need to be smart here. So try to write the first equation, like in the previous example. Try to write the first equation that actually can solve the unknown straight away, right away. Okay. Okay. So probably you want to do force, force in y equals to 0 first. Okay. Why is that so? You notice that actually in this problem, this is x, this is z, this is x, this is z, isn't it? This is y, this is z, this is x, this is y. So can you see that actually in y direction forces, you just have Cx, Cy and 400 Newton, right? Right. So if you do this one first, you can solve Cy straight away in this equation. So you assume y positive going this way. So positive Cy plus 400 equals to 0. So Cy equals to minus 400 Newton. Okay, so the magnitude of Cy is 400 Newton, but negative means that when you got negative answer here, means that actually initially you assume Cy going this way, right? Because you just assume it goes the positive y axis, but actually it means Cy goes the other way. Is it okay? So in the answer, it is either you do this, I mean you assume Cy going this way and you got 400 and you say that it goes the other way around, means it goes the other way around, or actually you initially you assume it going the other way around and then you should get 400, positive 400 here if you assume the other way around initially, right? So you got the first unknown, which is minus 400 Newton, right? This Cy. Next, we do moment about y axis in equilibrium equals to 0, which means that in equilibrium. So why we choose y axis? Because we will eliminate ax, az, bx, bz, and 400 Newton from the equation, right? Because this one is acting along y axis. These four they intersect the y axis, right? So we just need to check these three. What happened? So for 600 Newton load, we will have a moment about y axis because 600 Newton direction for the force is the direction of the force is going upward like that. This is the arm, isn't it, towards y axis? You curl that one, you curl around the arm, around the y axis, and then you have the negative moment because the moment, direction of the moment is minus y, right? So it is minus 600 Newton times the arm, which is 0.6 meter. And then let's check Cx. So for Cx, you have the arm with y. So we'll try. Let's try to do this. Cx going this way, the force, right? The force going this way. This is the arm, right? This arm. You curl that one. Can you see that actually you have minus Cx? You have minus Cx. So you have not minus Cx, sorry, minus moment of Cx. So you have minus moment. The load is Cx. The distance is 0.4 meter. You understand that? This one, this distance, if you do force is like this, you do moment about the distance, you curl that one. Can you see that you have y moment around y, but the moment goes the negative direction. Okay. And then how about Cy? Cy is let's say you use 400, positive 400, which meant go the other way around, something like that. Okay. So for this one, for this Cy, it will have moment, but this moment is, if you take this distance 0.6 meter, the moment will be along the z direction. Right? So Cy won't have moment about y. So you have this equals to 0. So you solve that one, 600 times 0.6 divided by 0.4. So you got Cx equals to minus 900 Newton. Alright, again, what does it mean by Cx equal to minus 900? It means that the magnitude is 900, that's fine. But the direction is initially we assume the direction is in positive x, right? Cx. So now the direction should be pointing that way with magnitude of 900 Newton. Right, so we got these two, Cx and Cy is by Cx. So we left with just four, Ax, Az, Bx and Bz. Right? So next, let me erase this. Okay, let's do moment about x. The reason is because when we do moment about x, at least straight away we can see that we can eliminate Ax and Az, the unknowns, these two unknowns from the equation. Okay, Ax because it is parallel, and Ax and Az because both they intersect the x-axis, right? So they won't have moment. There is no arm. The idea is that there is no arm, then there's no moment. As simple as that. And we will check the rest of the unknowns. I mean the forces. Sorry. So mx equals to 0. Okay, moment about x equal to 0. So we don't have moment for these two. So how about bx? See, so bx, it is parallel with x-axis. Again, same like ax. So bx won't have moment about x. Alright. bz, you go up, upwards, right? And then this is the arm. Okay, your palm will face the arm towards the x-axis. You curl around the axis or around the arm, and then can you see that actually you have moment about x? This is x, isn't it? Okay, so you have, and it's the direction is positive, so you have positive moment of bz, force bz, with the distance of 0.6 meter. Alright, don't have this. And then how about 400 Newton? So for 400 Newton, you don't have the moment for around x. Why? Because if you extend this, actually this line of action will intersect the x-axis. Same like the z, okay, the az. So there will be no moment for the 400 Newton load around x-axis. How about 600 Newton? So for 600 Newton, can you see that actually in this figure, 600 Newton will cause two moments. The first one is the moment for with this distance, the one that we just did for the my, right? 600 times 0.6 negative my. Another one is 600 times this distance, right? This distance. Okay, so you have positive moment of 600 Newton load times the perpendicular distance of this, which is 1.2, 0.6 plus 0.6. Alright, try again. 600 Newton going upwards, the force, this is the perpendicular arm, curl, and then you get this direction. So this direction is positive x, positive moment, load is 600, the arm is 0.2 Newton. Okay, so the other two forces, Cx and Cy. How about Cy? Cy actually it won't have moment. Why? The reason is because, again, same like 400 Newton, if you extend this line of action, it will intersect the x-axis. So there is no arm. Okay. But Cx here, because it's parallel with x-axis, it will definitely have moment. Okay. So for the Cx, because the Cx here actually the direction is like this, with the value of minus 900 Newton. So it is actually the other way around, right? 900 Newton load magnitude, direction should go minus x, right? So you can do either way, but let's go with the direction that way, because we know that this is the correct direction, right? And use the magnitude of 910. Okay, for CX, can you see that actually we have two arms. The first one is, if you assume CX going this way, okay? One is this arm, 0.4, okay? If you do moment, it will be my, the one that we did just now. And another one is, if you consider this arm, okay, 0.6 perpendicular arm, will be moment around the Z, isn't it? This Z, okay, for CX. So there is no moment for load CX about MX, about the X direction, right? So the last one is CY. This CY will have two moments. One is the moment about what? About this with this arm, which means that it will go in X. Another one was the one previously, the MY, which is CY here with the MZ. Sorry, we have not done the CY for a moment before. Yeah, we didn't use them. Okay, sorry, we didn't use CY for the moment before. So for CY we have two moments. One is with this perpendicular distance 0.4, so we'll have MX, the one that we're going to put here. Another one is with this arm 0.6, so we have MZ. Okay, so for the MX, you know that the CY is minus 400 Newton, which means that, again, what does it mean? The magnitude is 400 Newton, the direction is that way around from the initial assumption, right? So if we go in minus Y direction and we take this 0.4 meter arm, okay, so you have minus moment, isn't it? Minus moment in X direction, and the magnitude is 400, okay, and then the arm is 0.4 meter, equals to 0, right? Minus, because it goes this way, we curl, and then you have this minus M direction, okay, positive, negative. 400 is the magnitude of the CY, and then 0.4 meter is the perpendicular arm, okay, this arm. Alright, anything else in moment about X? No, so equals to 0. Here you can see that we just have one unknown, which is BZ. So we can solve this straight away. 400 times 0.4 and minus 600 times 2 divided by 0.6. So BZ is minus 933.33 Newton, right? So BZ here is minus 933.3 Newton. Again, what do you mean by minus here? The magnitude is 933, but the distance, the direction is the other way around. So it goes minus Z direction, right, for BZ. Okay, we have three more, 1, 2, and 3. So the next one that you can find it straight away is actually AZ, right? Because you can use summation of forces in Z direction. You have AZ, you don't know AZ, you want to find that. You have BZ, you have 600 Newton. So you can use summation of forces in Z direction is equals to 0, right? So you have AZ minus plus BZ or minus BZ, whatever. But the most important thing is that it should be correct here. It must be plus AZ minus 933.33, okay? And then you have plus 600 because it goes up. And what else? No other forces in z direction equals to 0. There are only 3 forces. So you can solve AZ here. So AZ is 600 minus 93.33. 333.33 Newton, which means that 333 1/3 of that, right? 333. So AZ here is minus 333.33 Newton. Right? 333. So only two left, AX and AX. Okay, again, what does it mean by this value? The magnitude of AZ is 333.33 Newton, but the direction is going downwards, not upwards. It is opposite of the initial assumption, right? Okay, next, want to find AX and BX. So you can do moment about, what else? MX. Okay, we can do moment about MZ. We have done MY, MX, and MZ. So we can do moment about MZ. Okay. Let me erase this. It'll be easy. Moment about Z equals to 0. Alright. So moment about Z equals to 0. No moment of AZ, no moment of AX. There's no arm, okay. So for BZ, given distance, we will create moment about X only, this BZ, okay. So there is no moment about X for about Z for BZ. And for BX, you will have moment if you consider this arm, okay. So look carefully. BX, we assume it goes positive X this way, okay. And then consider this arm. This is the force Bx, okay. That is the arm, 0.6 Newton. So you curl around that, and then can you see that actually this one will go downwards. So it will be minus moment of Z. The load is Bx. The distance is 0.6 meter. Minus moment, okay, going downwards. Positive Bx. The magnitude is Bx. The distance, the arm perpendicular distance is 0.6 meter, right? And how about the what else? This 600 Newton. 600 Newton, you have this 0.6, but it will create moment about the Y, okay? How about this CY? This CY will have, actually it has two vertical arms. One is this and one is this. This one will create moment about X. We have done before, right? To do this one in MX with 0.4 meter distance, but this one with this, okay, it will have moment about Z, right? So you consider this CY, okay, it should be that way, okay, CY 400 Newton, but it is actually the other way because it's minus the other way. And then this is the perpendicular arm, which is 0.6 meter, okay. You curl that, and actually you can see that actually this thumb will point in the positive negative Z direction. So you have for this CY, for the moment about Z around Z axis, you have minus moment. The load is 400 Newton. Okay, don't get confused with this minus, right? The distance is, the region is 0.6 meter, right? Okay, how about CX? Previously, CX, we have used CX with this particular arm, right? For the MY, previously, check that one. But there is another arm, which is this arm. 0.6 plus 0.6, 1.2. Alright? 0.6, 1.2. If we do this, Cx, okay, though actually now, be careful. Cx, the direction is actually pointing the other way around. Alright? Because it's 900 minus 910. Minus means that it goes the other way around. So go the other way around. Palm facing this direction. I mean, you take this arm, 0.6 plus 0.6, 1.2. You curl that one, so you have positive moment, right? So we have positive moment. The Cx is 900 Newton. Don't get confused with the minus value here, this minus sign. And then the R again is 0.6 plus 0.6, which is 1.2 meter. Right? So this equation, you just have one unknown Bx, you can solve the unknown Bx. Okay, hit the calculator. You got 400 plus 0.6 minus 900 times 1.2 divided by 0.6. So you got minus 1400 Newton. Alright, is it minus or no? Actually, it's not minus. Plus. Yeah, let me again 400. Okay, let's do this. 900 times 1.2 minus 400 times 0.6. So you got 840, but you go the other way around, divided by 0.6. So okay, so the initial assumption was correct for Bx. So Bx is positive 1400 Newton. Okay, the direction is okay. Finally, you can find the Ax, the final unknown. To find Ax, simply use solution of Fx equals 0, because now all the forces that in x direction, only Ax that you don't know. You know Bx, you know Cx. Okay, so Ax plus Bx plus 1400 Newton. Okay, this one, this one, this one. Okay, this one. So Cx is minus 900 Newton equals to 0. Ax equals to 1400 minus 900, 500. So Ax equals to minus 500 Newton. Right, so Ax equals to minus 500 Newton. Again, what does it mean by that? Magnitude is 500, but it goes that direction. Okay, in this configuration. Okay, so what is the implication of this? You have three. Remember, you have three bearings: A, B, and C. So they should be able to withstand in this configuration. They should be able to withstand the resultant of this individually, right? So that it won't fail.